Hello everybody, my name is Pierre Sutra and I will present in this video the work we have done with the Smile library in the Cloud Button project. So Smile is a well-known machine learning library for Java. It allows to mine datasets using modern algorithms. And we have used the Crucial framework to port part of this library to serverless. So let's first investigate how Crucial was used to do this voltage. And we'll use this to do this. We'll use the following two examples. So this is the Iris dataset. So the Iris dataset is a small dataset which is kind of a classical benchmark of machine learning libraries. So in this dataset, we have several flowers, and we need to sort them based on the image. So in this program, the test iris program, we are loading the dataset, executing a learning phase with the random forest algorithm, and output the number of errors. So let's run it in the cloud. So the expected number of errors is 0, which is what is happening. So this is the serverless execution, and the serverless execution, the serverless program, is very close to the original program. So what is necessary as modification is twofold. First, saying that the task which are executed to create the random forest are in fact a serverless task. This is done by changing the executor service with a serverless executor service. Here, this is the line to run it in the cloud, and previously it was executing as a classical multi-threaded library. The second thing to change is the shared object, because the task are constructing a shared object, which is the forest, which is the result of the computation. And in this particular library, they are doing a second object, which is called the prediction matrix. So the prediction matrix is computing what is called the out-of-back precision of the forest. That is, as you are constructing the random forest, with the input set, you can check at the same time what is the error rate of the forest based on the input data. And this is done concurrently also in the original code. And in the serverless part, we have done the same. So we have kept this logic intact, and this is stored in these two objects. Those two objects are the objects which are shared between the different threads which are creating the task. And these objects are stored in the Crucial DSO layer. So when one wishes to execute the serverless implementation, the serverless portage of the random forest algorithm in the Smile library, one needs to deploy. It is necessary to deploy first the task, and second the storage system. So this was done before running the test iris method, but let's look briefly at how it is done otherwise. So to this end, we have created a set of tests. So the deploy lambda is creating a package which will be loaded in AWS Lambda. This is so far we are using Lambda to as the function as a service infrastructure to execute the task. It is possible to, and we have some upcoming support for things like Knative or Google Function. And for Crucial, we are using the DSO layer, the storage layer of Crucial. We are using Kubernetes. So if we do a kubectl get all, we'll see that some nodes are running in the service, some pods are there, and they correspond to the pod that are holding the storage layer. So here we have the log in AWS of the executor service, which is in charge of executing the task, and we are using, in fact, GCP as the storage layer, a cluster called DSO in Kubernetes, and both of these two systems, the DS layer and the AWS Lambda, are located in London in different data centers, but they communicate between each other. So that's the basic component of the crucial framework and how we have ported the random forest algorithm of the SMILE library. And this approach is applicable to other algorithms in the library to port this single machine algorithm to the serverless infrastructure. So let's look now at some results which were run to have a better understanding and compare what is the vanilla version providing versus the serverless version. So here, in the plot on the left, we ask for several datasets, the performance in second, the running time of the learning phase of the random forest. And we compare three use cases. We compare crucial, so our implementation, serverless implementation, and with the vanilla version of SMILE, running on a laptop and on a server class machine, which contain 80 core, multi-threaded core, hyper-threaded core, sorry, which in the end is 160 hardware thread. So here we have the execution time for each of the dataset, and the dataset are from left to right of increasing size. This one is about half a gigabyte, and this computation is intensive. That is, the difficulty is not the size of the dataset to process, or it's not memory bounded, it's compute bounded, because the computation of the forest is expensive. You have to compute the Gini index for each of the dimension of the element, and this is an intensive computation. So here we see that, well, with a laptop, one increase dramatically the time to execute the learning phase. And this is done with 50 trees. In fact, if we want more trees for better accuracy, what we'll see on the left, on this figure, on the right figure, it can be up to have a very good accuracy up to 20 minutes. So it's a very long time to wait for the learning phase. And it's of course possible to use a powerful machine to reduce this time. And this is, for instance, the case of the SMILE 160 curve. In this case, we are using a server class machine with many hardware core, and we are able to reduce the time to execute the computation to around a fifth of what was necessary for the laptop. And what we can see here is the bar in orange is that Crucial is providing on the fly the same capabilities as this high tier machine performance. So we have a very similar performance with Crucial, and this is without providing, without requiring an advanced hardware. This is just done on the fly by saying that we want that many tasks executing, and to construct the random forest. So on the right hand side of the figure, we have another plot, and this plot we are executing. We are using the credit card dataset. So this dataset is a set of transactions. Some are fraudulent, others are not. And the goal is to recognize fraudulent transactions. And here we have the measure, a classical measure, which is called the area under the curve, because the dataset is biased toward non-fraudulent transaction. And so the area under the curve is a common metric in statistics to capture the efficiency of a classifier for biased dataset. And the closer the measure is to one, the better the classifier is. Of course, when you're adding more trees, the classifier is getting better. And also the time to compute the classifier is higher. So here we have 200 trees, So it's not on this plot, but as I was mentioning previously, if you use the laptop, it's 20 minutes the time to compute the classifier. So with the big machine, you reduce it to 50 seconds, and with Crucial, it's even faster because you can have more processing power to do the computation. So this closes our video. In this video, we have seen the use of Crucial for in the context of a machine learning library, how to port a single machine library to serverless with a few modifications, and how it can offer on the fly performance comparable to a high-tier machine by using the serverless resources. Thank you for your attention, and enjoy the rest of the videos and presentations.